Okay, your first check of your review is going to be problems 1 through 16. Let me get the calculator up. You will need the calculator because there are some trick problems in this first section. On the first page, just show what you know about the concept, draw pictures, give examples. This is going to be a completion grade. I will talk about some key information that you need to have. We'll do that in class. But I'm going to go straight into our problems 1 through 16. Make sure you have used the right formula, have the correct setup, and get to the correct answer. So on the second page is where the problems start. This first section says Pythagorean Theorem problems. Find the missing side links, leave your answer in radical form as show work. So here, because we have just the right angle with that box showing that that's 90 degrees, and we have two side links, we're going to always do a squared plus b squared equals c squared first. So understand a and b are the legs, doesn't matter which one, they're interchangeable. So I can say 9 squared plus x squared, that's the other leg, equals 15 squared. Hypotenuse is always opposite the right angle. So 81 plus x squared equals 225. And then to solve for x squared, we're going to have to subtract 81 from both sides. X squared is going to equal to 144. And then we're going to take the square roots of that. I believe that's right. Yeah. And so we should see that our answer is A. Alright, so because this is a rectangle, there are 4 right angles. And so I can use Pythagorean Theorem with the diagonal, which is Kim's path, to find that length. So his path is the hypotenuse. So again, a squared plus b squared equals c squared. So 100 squared, you need a calculator for this. 240 squared equals c squared. Okay, it does come out to be a perfect square. Now, of the test-like or district assessment, it'll be number 3. We had this as a warm-up last week. Make sure you can label the given information on the figure correctly, because this is the height of the broken tree is 8 feet from the ground. That 8 is this vertical distance here. This is the tip of the tree touches the 15 feet from the trunk. What was the height of the original triangle? So height of the original triangle is what we're trying to find. I can use, again, Pythagorean Theorem to find the hypotenuse, which is c, and then add to get to my height of my original. I want you to try to do this one. I'm not going to set this one up for you. Now, I gave you a hint on 4. It says PF and PD are radii. So that means they're both radius, so this would have the same measurement. So this would be 200. And then if you look, SD is perpendicular because there's a box. So we have a right triangle here. But make sure you label the hypotenuse, which is 450. You add the 200 and the 250, we get 450. And we're trying to find SD, which is the leg. So basically, we're going to have 200 squared plus x squared is equal to 450 squared. Go ahead and solve for x. So there's our setup for Pythagorean Theorem. I think you can work this out. Now, this next section is using special rights. You're going to have to start with the side that's given to you, label all the parts to that triangle, and then move on to the next triangle. It might help to separate them. So if I start, the side that's given to me is 7. So if I start with this triangle, and I'll make it a little smaller, and it's 45. So that means both legs are 45, and the hypotenuse is just that leg times the square root of 2. That number in front of the square root of 2. So now that I labeled that 7 square root of 2, I probably should have did that in green so you can see the different triangle, 7 square root of 2. Now I'm looking at the big 45, 40. The other leg is also 7 square root of 2, and the hypotenuse is whatever the leg is times square root of 2. My leg is 7 square root of 2, but then I'm multiplying that by square root of 2. You can do this in the calculator to check your reasoning. So if I have 7 square root of 2, make sure that times table is outside the radical, not underneath the radical. And then just do a square root of 2 again. I get a whole number answer, which is 14. Okay? And the reason that is because these two are inside, underneath the radical, because the 2's are only things that can multiply together. So this is basically 7 times the square root of 4. And what's the square root of 4? That's 2. And 7 times 2 is 14. But your calculator can give you the correct answer if you plug it in correctly. So, on 6, you need to start with the triangle that you have a side measurement for. This would be my 45, 45 with the leg of 5. So both legs are 5. If you want to redraw them to help you problem solve, do so. Remember, the hypotenuse is whatever that leg, square root of 2. So I'm just going to put 5 square root of 2. The 5 goes in front of the square root of 2. And if I notice now, this 5 square root of 2 is part of the 30, 60, 90 triangle, and it is the short leg. So if I'm looking at my 30, 60, 90, and I know it's not to scale, 5 square root of 2, I always start with the short leg, then go to the hypotenuse, double that. That would be 10 square root of 2. And then, oops, I didn't put that at the hypotenuse, sorry. Hypotenuse is across from the 90, so that's 10 square root of 2. And then, to get to the long leg, I take whatever the short leg is and multiply it by radical 2. Radical 3, excuse me. Short leg. So basically, 5 square root of 2 times square root of 3. Plug it in. Only the 2's and the 3 gets multiplied together. And see if you can get the simplified answer. We'll check it in class. So number 7 is very similar to number 6 in the sense that we start with the 10. We know that the 10 is the short leg. Over here is the hypotenuse. And then we have the long leg. If this is my short leg, then my long leg is just 10 square root of 3. The number in front of the square root of 3. And then if I look in my next triangle, again, that 10 square root of 3 is the short leg in that triangle. So to get to the long leg, you take whatever that short leg is and multiply it by the radical 3. I'm going to let you try that one. And number 8, of all the problems, number 8 is the one that's very similar to the test. It'll be a 45, 45, 90, and a 30, 60. Okay, it'll be a combination. So please start with the part that's given, which is a hypotenuse. Don't pay attention to that P. It's a typo. Start with the hypotenuse and get to the short leg, which will help you get to X, because that's the leg in the 45, 45, 90. All right, and then the next section you have is Sohcahtoa. You'll be using trig. So the steps are all going to remain the same. Circle the angle. Label the parts in relationship to the angle. X would be opposite. 18 is the hypotenuse. Figure out what trig function that is. Opposite and hypotenuse is sine. Write sine of the angle, which is 58, equals opposite x over hypotenuse 18. X is on top. Whenever x is on top, you multiply. So this is 18 times the sine of 58. Please put it in the calculator correctly. Same thing we're going to do on 10. Circle the angle. Label the parts. X is adjacent. 10.6 is the hypotenuse. What trig function deals with adjacent and hypotenuse? Correct cosine. Cosine of the angle, which is the 27, equals adjacent over hypotenuse, 13.6. Again, x is on top, so x would equal 13.6 times the cosine of 27. Please always start with the the side measurement. So understand, you have to have the proportion, the ratio of the equation, and then show what operation. Now, if you don't have a calculator that can do trig, please at least get to this part to receive credit. That at least shows me how you're going to type it into the calculator. So I'm going to leave 11 for you to do, which is very similar to number 10. And then we're going to talk about 12. Circle the angle. 6.1 is opposite. X is the hypotenuse. That is sine. Sine of 41, the angle. Always do the angle measure, is equal to opposite 6.1 over hypotenuse, x. Now here, x is on the bottom. So we take all of this, the sine of 41, and put it to the bottom, and take the x and put it over to the top, to the left, basically. So x equals 6.1 divided by sine of 41. And that is what we're going to do, plug it in to receive the measure of that side length, that missing side length. Now when you get to 13 through 16, you're going to have to draw a picture. Please get in the habit of always drawing right triangles. I like to have mine in this following orientation. Angle depression is the same as angle of elevation. Depression means going down from a horizontal line. So you would have to have an imaginary horizontal line. But this angle here is the same as the angle inside, above the horizontal line. So I'm not going to worry about the definition. I'm going to use a property that they're the same and put the angles there. That's who we're trying to find. 48 feet, we did this one as a warm-up as well. The base of the scaffolding from the crib is the base, so that's 12 feet, that's at the bottom. This would be adjacent. And hypotenuse, remember you write the trig, because cosine and the angle, which is x, equals adjacent 12 over 48. And when x is on the inside of the triangle, you have to do what? Exactly if you wrote inverse. So x is equal to cosine negative 1, 12 divided by 48. You have to type that into the calculator. This is what I'm saying. If you don't have a calculator, cosine, and you 12 divided by 48. Because I don't think it will do this on your phones. But just remember, get it set up to receive credit when I check 1 through 16. To get the answer, we're going to round to the nearest degree. Since that's 7.5225.5 gets rounded to the degree of 76. So I need you to draw your right triangles and get to your answers. We're going to check to see if you can just start off with the right triangle. It doesn't have to be to scale, and label the parts. Says angle of depression, but remember it doesn't matter. It means above the horizontal x. We have 32. We should have 76 feet as the height. And we're trying to find the zip line, that's the x. So see if you can set that one up. This one is not trig, but it's still a right triangle. We have 18 feet up, so that's the vertical. 6 feet from the tree, that's the base. Trying to find that distance, the hypotenuse. And 16, last but not least, always right triangle. 60 degrees is the angle. Always use it with the horizontal line. We know that it's 28 feet from away, standing away, so that's going to be the base. And we're trying to figure out the string, that's the hypotenuse. You can use special rights here or trig to get to your answer. Please show some type of work to receive credit. All right, thank you, and we'll do the next section for the next check.